Hello, everyone, and welcome to Key Workflows within the PDM Collection webinar. My name is Juliana, and I work in marketing here at MicroCAD. And today's presenter is James Dumont. At today's webinar, we will go over some key workflows within the Autodesk PDM Collection you may find helpful and saving time. Throughout the webinar, you can ask a question at any given point on the left-hand corner. You can ask Jim to revisit a step or ask any questions. This is your time, and we want you to make the most of it. And in the upper left-hand corner, you will find links to our social media, website, and YouTube channel. So yeah, be sure to be checking that one. We post all of our webinars there at the end, so you can share with colleagues or rewatch it on your own time. And without further ado, we'll pass it on to Jim. Hi, Jim.
Hi, Liana. Thank you very much. Hello, everyone. Good afternoon. I'm just going to minimize the screen a little bit and share mine. Let's see here. And we'll share this guy. So you're not distracted. I'm going to shut my camera off so you can actually focus on the actual screen that I'm going to be sharing. So today's presentation is just on some of the key workflows within the product design collection. There's so many to address. There's no way to really cover those properly in like 30 minutes. I'm going to try to keep to the time frame that we have today. The previous one, I did go way over. So if any of you are on this session that were on the previous one, thank you for hanging in there. I'll try to stay on point today. So this is just going to cover a couple of different workflows that might be of interest to some of you. Feel free at any point in time to reach out to Liana and anyone at MicroCAD. If there's other workflows that you think might be interesting, we can definitely guide you and help you and demonstrate those workflows. Today, we're going to focus on the product design collection. There'll be no Vault involved here, but Vault is always a key component to everything we're doing with files that we create. So I am wearing my Inventor hat. Oh, sorry, I took my camera off, but I do have my Autodesk Inventor hat that I got at Autodesk University right before COVID. So I am, basically trying to keep in the spirit of everything, especially since Autodesk University was last year. If any of you attended, please let Juliana know to put in the chat window. I'd like to know if any of you have attended and what your thoughts were. I was not able to make it this year, but I'd like to get some input. All right, so basically, this is going to be a real small subset of slides. This is some similar slides to what I did in my last presentation. It's about extending the capabilities beyond the 3D design, because a lot of us design and we'll come up with some iterations, but we then have to somehow get it to manufacturing, maybe some sharing, getting some input and things like that. So we're going to look at different workflows within the collection. All right. When we start looking at the collection, the primary product that we always think about is Inventor. That's typically where we start our design. But the collection has so much more, from design engineering to production and to sales and service. So there's an awful lot that's in here. Again, I can't do it justice in 30 minutes, but we're going to try some key work to show some of the key workflows. Some of the capabilities that we have with Inventor, when you start utilizing all of the capabilities, is that we actually have a lot of success with our customers that they're able to spend more time innovating. They can actually design and get more iterations versus designing and drawing only a few. But with the software that they have with the collection, they can actually do much more innovations. And they do that by using the tools that's actually in the collection. They're able to improve their performance, able to work better, faster, more efficient. And because of all of that, they're able to win more business because now they can actually quote more accurately. They can quote more timely. So they are winning more business. And the streamlining manufacturing is, if you can get the files from engineering to manufacturing in a timely manner, you're hitting those timelines and you're shipping product when the expectations are there. So you're not really falling behind on anything like that. So we are going to start with Inventor. That is the primary foundation of the collection. So what makes Inventor such a great design tool? It enables you as a designer or engineer to focus on your design and less on where are the commands, where are the tools. There's built-in sheet metal, frame generator, tubing pipe for assemblies. Some of these things we've already covered in the past, and we're going to focus on basically what they call top-down modeling, working in the context of an assembly. The flexible modeling methods are great. You're going to see how we're working with parametrics, and we're not doing any direct editing or freeform today, but they all interact directly inside of Inventor. These are just some of the tools that are in the collection. We have the tolerance analysis, which we showed in our last presentation, factory design. So if you do have new product and you do need to set up your factory for it, the factory design layout is a great utility to lay out everything you need, conveyors to equipment, shipping, inspections, robots, whatever is necessary, you can do that with the factory design utility. Nastran, we're going to talk a little bit about that as far as some analysis, and that's where you get better product. You can be assured that the product's going to do what you designed it to do. Inventor Cam, that's something we're going to be actually discussing today as far as manufacturing, CNC. And the nesting is, again, it's about using sheet metal parts and maximizing your raw material usage. So built into the collection is Nastran, but we're going to focus on, we're not going to get into nonlinear fatigue or thermal analysis, but that's all capable. But again, we're trying to keep within a 30-minute presentation, but I'm going to show you some simple stresses and how we go from an assembly to that, and then back to design. So the Inventor Cam is going to be a big part of the focus today. There's two choices with that, and I'll talk about that when we get to it, but the ability to create CNC toolpaths from your designs inside of Inventor it's a great productivity boost. Big thing I want to talk about is the Autodesk Fusion 360. So that is part of the collection, but it's also with the Inventor, or I'm sorry, I should say the Product Design Collection 2023, the ability to communicate with other users that are using Fusion and Fusion 360, bi-directional capabilities has been greatly improved, and you're going to see some of that in today's presentation. So we're not going to focus on generative design. That's going to be a presentation all in itself because it definitely needs that. But the Fusion 360 has so many capabilities as far as design and fabrication, additive for 3D printing, and there's also Fusion 360 Cam, which is one of the things that we're going to focus on today. All right, so I'm going to back this up. Let's get over into the presentation. All right. So in today's presentation, I'm going to focus on this little dirt bike, and in it, I'm looking at it, and I want to be able to design a new linkage over here. What we had before, it works, but I need something to be a little bit stronger, a little bit lighter. I want to be able to make sure it's going to actually handle the loads. So what I want to be able to do is in this assembly, I want to be able to design using the geometry that already exists. Again, this is one of the workflows. So in here, in my assembly, I'm going to create, and I'm just going to call this linkage 3, and I'm going to use a metric template file. As I said, I'm not using Vault. That message right there, I wanted to know if I wanted to log in. We're going to focus on just the collection today. So in here, now that I've done that, so the primary focus is I'm working with a part file. But if I wanted to, I can change my view so that I can look at the other parts not in so phantom or translucent, but I want to be able to see things a little bit more dynamically. So in here, I'm going to create a sketch on a plane, just as you would normally, but I'm just doing it in the context of the assembly. And I need geometry from these other parts to help me design this. So I'm going to start projecting some geometry here. So now the translucency, I want to get back to that. So I'm actually going to come back over to my view, switch this back over so I can see what I'm working on a little bit more dynamically. So I'm going to create some geometry. And I'm using the geometry from the assembly to help me dictate this linkage so I know everything's going to fit. So this looks good. Now, one thing that AutoCAD always struggles with is just creating some geometry. So what I want to do is create some arcs between here. And I can just very quickly just click and drag. And I'm not worried too much about the size. I just want my design intent to be captured. If you've done this with AutoCAD, you know you got to create the circles, tan, 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 you're trimming, you're extending, you're offsetting. It's a lot of work to create this geometry. I can just use geometric constraints. I want these geometries to be tangent. So the arcs are tangent to the circle, and I'm just going to walk around and just kind of enforce that intent. That's how I want the geometry to behave. So now at any point in time, I can throw some dimensions on this. And let's make that 30. So that's a little tight. I'm not really crazy about that. So it's just a matter of changing the dimension. And everything maintains the geometric constraints, the dimensional constraints, everything is tied together. So now what I want to do is actually make this a solid. So I'm going to extrude my geometry. I'm working in the middle of the assembly, in the middle of the part, so I want to extrude it in both directions. I've already measured it, so I need about 20 millimeters thickness, so I'm going to specify 20. So it's going to split it. It's going to go 10 in each direction, and this is good. That's what I'm looking for. Now, only thing that I've done here is just sketch some geometry, created my first particular shape, but just by doing that, the geometry is actually tied together and actually controls the animation of my assembly. I do need to clear some material out over here. Excuse me 1 second. All right, so my geometry was tied together. So now what I want to do is, this is a clevis, so I need to make room for this. So I'm going to measure from the top over here. So it's about 4.5 millimeters. I want a little clearance. So I'm actually going to work on this. As I'm sketching, I can create my dimensions along with it. All I have to do right now, it thinks I want to add material to my solid. I actually want to remove material. So by just dragging this, it'll automatically switch to cut. It's going to remove it. And I'm going to cut 5 millimeters into it. So this looks good. Let's take a look at it. And as I start to move this, I start to see a bit of an issue right here. So at any point in time, if I choose to, I can simply just open this file up. I don't have to work inside of the assembly. I can work on it by itself. So over here, if I want to make some changes to this, I'll add some fillets to these edges. And 2 millimeters looks good. And as I switch to the assembly, everything's live and bidirectional, so everything associates and it updates dynamically. So no matter where I am, I don't have to hit save and update and go back and forth. As I'm working, everything is dynamic. So now that I have this, I have the ability, as I talked about earlier in the presentation, the PowerPoint, is I have Inventor Cam. So if I wanted to, I could switch over to Cam, create my setup, and start creating some toolpaths. However, realistically, most designers are not using the Inventor Cam. There's someone else in their company that's doing that. A lot of times it's the shop that's doing it, and they have machinists that'll run either Master Cam, Gibbs Cam, but now they're running Fusion 360. And if that's the case, I'm actually going to save this file now to do this. So the integration, or what Autodesk calls the AnyCAD, is how we tie Inventor to Fusion. So what I'm going to do is, I'm going to do this with conventional machining, so just 3-axis machining. And I'm going to take this file and I'm going to push it to Fusion 360. This is great for the shop that, again, you might have a separate license of Fusion. You might be going outside to a company that's going to be doing your CNC, and you can work bi-directionally associative with them. I'm going to specify the folder that I want this to go into. Now, because it's a demonstration, I'm going to be doing wearing all of the hats. I'm going to switch over to Fusion. So this is the Fusion 360 environment. The model is being uploaded to the cloud, and then it's actually being opened in the design environment within Fusion, and then it's going to switch to the manufacturer environment, or manufacturing panel within Fusion. Just takes a second or two. There we go. So you see the linkage 3 IPT, and it brings it directly into Fusion. It goes right into the manufacturer and already starts creating the setup. So I want to focus over here. So I'm going to work over here, set my Z. My Z is going to be right there. And that's going to be my, my origin for the CNC. So I'm going to start working over here. So this looks good. Then the only thing I'm going to do here, I'm going to create a couple of tool paths. I'm going to create a facing. I'm going to select the tool that I need. I'm going to do a 2-inch face mill. So that creates my first operation. You see the stock, I'm just facing it. And then what I'm going to do is some 3D adaptive clearing. I'm eventually going to put other geometry on this. So I'm going to switch over to like a bullnose end mill. I'm going to do a 1/2 inch. I'm going to change my maximum rough and step down to 375. And my fine step down will be 0.050. That's about all I need here. So Fusion is going to look at the geometry and understand how to remove the material very quickly, very accurately, and gives us best performance with the tool. So if I wanted to at this point, I'll just show you the little simulation of what I've got going so far. So it's going to face it and it's going to start to rough it. It's leaving material both axial and radial. This is just the roughing, just adaptive clearing, just getting rid of a lot of material quickly. Okay, I'll exit that. Now I'll switch back to Inventor. So as I'm designing this, I want the CNC operator to get started. So when I come back to Inventor, maybe I want to make sure this is actually going to handle the load. So what I'm going to do here is I'm going to create a representation. This is what they call a design view. And let's call this linkage. And then the only thing I really want to see is the link in this frame over here. And I'm going to isolate it. I'm going to remove all the other geometry from the screen. I don't need to see it. I want to be able to do a simulation. But what I don't want to do is look at the entire assembly when I'm really only focused on these two parts. So at this point, I'm going to simplify it for the analysis. This makes the calculations and the meshing a lot faster. So I'm going to simplify this. I'm putting the associativity on, so if I make any changes, this simplification will update. This looks good. And I'll hit OK. Okay, now What I'm going to do is switch over to my environment. I'm going to go into my stress analysis. As I mentioned in the PowerPoint in that slide, we have the ability to do linear, nonlinear, thermal, vibration, all kinds of things like that. Today, I'm just going to focus on simple stress analysis. That's going to be linear. I'm going to create a study. First thing I'm going to do is set up my material. I think steel alloy will be good for this. And I'm going to set up some constraints. So it's going to be fixed over here. And over here. I'm going to have a pin constraint here, here, and there. And I'm going to put a load right over here where the clevis will be. And I'm going to put about 500 pounds of force in that direction, in the Y direction over here. So you can see this is the load coming this way here. I've got my constraints, and because what I'm looking for is a safety factor of about 3. I want to make sure this is going to handle that load. These are just warnings because I'm not doing the full assembly. And for what I'm doing today, it's actually irrelevant, but I'm looking at some analysis as far as how it was simulated. So if I look at my safety factor, you can see the blue is about 15, and you can see that I'm really high as far as safety factor, about 15. If I choose to, I can probe. I can see what's going on over here. Oop, cancel that. I got out of my environment. Sorry about that. I accidentally canceled out of it. Let me get back to here. There we go. I went back to the assembly. Let's go over to here. Here's my analysis. Let me simulate that. There we go. But what I wanted to show you is that in the safety factor, we're way above our 3 is what we're trying to achieve. I'm looking at the colors. This is a little color index. Red doesn't mean failure. It's a chart. Red would be the lowest safety factor. I'm in the blue to the greenish area, so I'm really, really high. So most likely I have the ability to remove material. I can make this a bit lighter and still be within spec. So I'm going to go back to my assembly. Actually, I'm going to do it in the part file. I'm going to edit this a little bit more. And I'll create some additional geometry here. Now, I'm not being so careful as far as having to trim the geometry. My preferred preference is I work with a lot of closed profiles, and that's completely fine. So when I actually make a pocket over here, when I extrude this, I'm only choosing the profile that I'm interested in. I'm going to drop this down. It's actually going to do a cut. This looks good. What I forgot to do is, you know what, I need this on the other side as well. So I'm actually going to come over to here. This is just what they call a feature reorder. And I'm actually going to mirror this feature to the center of the part. So it doesn't matter when or how you work. I can always rearrange and change it. So I'll take this mirror and I'll bring it down. And I'm just going to edit. And I'm going to add the additional features to it. So it's on both sides. So you're not editing multiple times. The other thing I forgot was my fillets over here. So I'll drag this up here. So basically, I'm changing my timeline and I'm able to work dynamically. I don't have to worry about the order. If I make a mistake, I forgot something, I can always go back and change it and everything is good. I'm missing my fillets. All I do is edit my mirror and simply just add the new fillet. And we're done. So now if I go back to my simplification method and rerun my analysis, and I look at the safety factor, still way over 3. So this is going to be a very strong part. I could probably make these pockets even deeper, maybe change the material to aluminum, things like that, to really make other verifications to it. Go to my assigned material. Instead of steel alloy, let's try aluminum. We'll go with 6061 and see what that looks like. So now I'm going to do all kinds of iterations. Again, this is how you can improve your process. Instead of guessing, we know for sure. Look at my safety factor. Aluminum is going to be lighter. It's going to be strong enough, and it's going to work really well. Now, if I go over to Fusion, it still sees the old part. So what I need to do is my machinist needs to be updated to this. So I'm going to go to Inventor. I'm going to save my file. Here is my Fusion export, and I'm simply going to upload a new version so he's aware of it. It keeps track of all the history automatically. So when I'm ready to push it to my machinist, I'm going to do that on demand and let him know. And then inside of Fusion, he's going to get a flag saying it's out of date. Update it. All right, so the part looks good. I'm sorry, I'm going to switch back to manufacturer. And my tool paths are now out of date. So I'm simply going to regenerate them. If you hear any banging, I do apologize. I have a contractor doing some work outside, and it's carrying through the house a bit. One of the nice things about working from home. All right, so let's take a simulation. Let's take a look at what's going on now. So we've got the roughing, we've got the adaptive clearing, and automatically it included the pocket. So with other systems, you have to re-export the file. They have to import the file and start again. So they're not going to do any of the CNC until the very end, until the part is relatively finished. We can now do it in stages. We can also get some statistics. We know about how long this part's going to take. So right now, just the roughing, it's going to take almost 6 minutes. You can see 5:58. So about 6 minutes of machining time. And this is very accurate because it's all based on the feeds and speeds of the tool, the stock, the part, the type of material that it is, coolant, all of that information is taken into account. And so we have a rough idea about how long it's going to be at this point. And then as we start adding more tool paths, we'll get a good idea of what's going on. And then if they need to reduce the time, they can change strategies, maybe increase the feeds, maybe change some tooling, things like that, whatever is necessary. We'll switch back to Inventor. So everything looks good here. Finish my analysis. I'll come back to my assembly. Let's go back to the entire assembly. There's my new linkage. And so now if I'm actually ready to maybe visualize this, I want to show this to maybe management to make sure they buy in on this. I have the ability to improve the graphics a little bit, show some shadows, some reflections, show it on a country road. We have these image-based lighting textures that we can do. We have realistic ray tracing, so you can get very, very high quality results right from inside of Inventor. I did not have the time to actually start getting some really good materials on here. I'm going to try to work on that for the next time I present this so that it really looks good. A nice, nice black, nice some shiny materials, some nice chrome on some of the components. But we have the ability to visualize it in different environments. Right now, I'm looking at it in the country road. little road there, Desert Dawn. And we can even try it in a salt bed. A lot of options. You can see the lighting and the reflections all work. Everything is dynamic. So with that being said, let me get out of my PowerPoint. Are there any questions that came in that I could possibly answer? Switch back to my camera.
No, not yet. I will let you know if anything comes in.
Okay. So this is just a typical workflow. There could be many different types. And if you have anything that might be of interest to you with the frame generator, the tube and pipe, the electromechanical, the EMX exchange, we can set a presentation up just for you and your company based on your needs. And we would be happy to show you any presentation that would suit your company. So that is the end of my presentation. I hand over back to Liana. And just if any questions come in, be happy to answer them.
Thank you, James, for that wonderful presentation. And as a reminder for everyone, if you want to learn these topics in detail, you can always take a custom training with Jim or someone else on our team. We also offer group classes online. So be sure to be checking the MicroCAD website for future webinars. And that concluded our webinar today. Thank you everyone for attending, and thank you, James, for that presentation.
Thank you. Thanks, everyone. Appreciate your time. Thank you. See you next time.
Bye-bye.
Bye now.